Okay, I think I found the problem. As I've said, I think I've said this on a couple of occasions, that arrays work very oddly, and this is what I'm talking about. Um, you see, I created an entire method called copy array, and you would imagine that instead of having to go to the trouble of creating an entire method that's going to copy the array, you realize that it copies the array per index, going through an entire loop. That I should just be able to do something such as result equals I, and do the same thing. Multiple equals I. Well, when we do that and run it, we got something very odd here. What it's doing is it's treating result and I as one thing, as more parameters of I, instead of treating them as two different arrays. So that's why I'm putting them into my copy array methods. And in my copy array methods, I made a mistake. As you can see, this one is copying what's in I and putting it into result. And this one's supposed to be taking I and sticking it into multiple, but instead it's sticking it into result again, being redundant. So let's put it into multiple. Alright, so let's run it. Okay, well, it seems to be working and this actually happened with my last program, and for some reason when I stuck in a number higher than 2 to the power of 3, for example, which should be 8, it didn't work. So let's see if it'll work now. It probably won't. I probably will have to do the same thing I did in the other one. Okay, it gave me 0, so that's not a good sign. So what I'm thinking is it's not this multiple variable is somehow changing. Don't know how, but let me copy it into the actual loop. This way it kind of resets itself each and every time. Let's see if it works now. Yes, it works now. So it's resetting itself each and every time. Now it's 8, and let's put in the next one. I actually have this memorized. Let's see how well I do. Okay, so let me go into maximize here and zoom in. So 2 to the power of 4 should be 16. And where is the result? 16. I'm wondering if I can get this on top. There we go. So 2 to the power of 4 is 16. Now 2 to the power of 5 is 32. And 2 to the power of, let's see, 2 to the power of 6 is 64. And now 2 to the power of 7, if you can see, I'm changing it with my keyboard. 2 to the power of 7 is 128. 2 to the power of 8 is 256. 2 to the power of 9 is 512. And 2 to the power of 10 is 1024. 2 to the power of 11 is 2048. 2 to the power of 12 is 4096. 2 to the power of 13, right? Is that what we're on? Is 8192. Okay, next one is going to be 32768. 16384. I always skip that for some reason. But the next one is going to be 32768. Next one's going to be 65,536 or something. There we go. Next one's going to be, this is getting hard. This is 2 to the 16th power so far, so I'm going for 2 to the 17th power, which should be damn it, I forgot. Let's see, 13172. Now it looks so familiar. And the next one would be 262 144, and the one I memorized up to the most was 524 288. Yeah, and that's the most I know. Then it keeps going and going. So my goal was to get up to 2 to the 32nd power. That's when I was studying computer networking. And in order to subnet, or in order to work with IP addressing, you had to memorize at least up to 2 to the 7th power. And if you wanted to be more advanced, you can memorize up to 2 to the 32nd power, or use a calculator. And as we are now using IPv6, there are 128 bits, so I don't think anyone's going to memorize that much. So, alright, so we have exponentiation working. Let me put the console right back where it belongs. Oh, why isn't this working? Let me close it and try to get it back. There we go. So, again, I don't think my source code is using the most efficient method for at least multiplication. Definitely not. Maybe I might do one more video after I tackle division and the remainder methods to further improve the efficiency of the product method. So anyway, we've hit a big milestone once again. So let's look at everything we've completed so far in this series. We've done all of this, we've done all of this, and we've also done this. Now all that we're missing is division. And it's actually, I predict it's actually going to be much simpler than you think. It'll probably be the same way we had addition, and then we just did the exact opposite of addition and subtraction. I imagine division is going to be, I imagine, well, let's just try stealing the code out of multiplication and sticking it into division and seeing what happens. Alright, so that's about it. Let me stop the video.